Okay, so let's look at another example of stoichiometry calculations and limiting reactants. So I'm going to write out a problem and then we'll go through the steps together. So here is the question. It says carbon and oxygen react to form carbon dioxide. If 10.0 grams of carbon reacts with 10.0 grams of oxygen, how much carbon dioxide can be produced? And then also, what is the mass of the leftover excess reactant? Okay, so this problem encompasses everything that we've covered so far, where limiting reactant, theoretical yield, excess reactant. So when you have a problem like this, the first thing that you need to do is you need to write the balanced chemical reaction. Okay. So we have carbon and oxygen react, so they're the reactants, to form the product carbon dioxide. So carbon is C plus oxygen. Remember, oxygen is diatomic, so oxygen means O2, not O. To form carbon dioxide, CO2. So that is the formula as it's written. Now we need to make sure it's balanced. So on the reactant side, I have 1 carbon. On the product side, I have 1 carbon. On the reactant side, I have 2 oxygens. On the reactant side, I have 2 oxygens. So it is balanced. So there's my first step. Write the balanced chemical reaction. Now I am asked how much carbon dioxide can be produced. So remember, the amount of product that can be produced is from the limiting reactant, and this is called the theoretical yield. So I need to calculate the theoretical yield individually with each reactant. So 10 grams of carbon, how much carbon dioxide can I make? 10 grams of oxygen, how much carbon dioxide can I make? So remember, the previous examples we were talking about moles. We're no longer talking about moles, we're talking about grams. So I'm going to determine the limiting reactant and the theoretical yield next. I'm going to determine the limiting reactant and the theoretical yield. So the way I'm going to do this is I'm going to say first with carbon, I'm going to say 10.0 grams of carbon. Then I'm going to convert grams of carbon to moles of carbon using the molar mass of carbon. Remember, the molar mass of an element comes from its atomic mass on the periodic table. So carbon is about 12.01 grams per mole. Remember, we want grams to cancel. 12.01 grams of carbon in 1 mole of carbon. So I've gone from grams of carbon to moles of carbon. Moles of carbon. Now I'm going to use the mole to mole ratio to go from moles of carbon to moles of carbon dioxide. So that means I want moles of carbon on the bottom, moles of carbon dioxide on the top. It's a 1-to-1 ratio, 1 mole of carbon to 1 mole of carbon dioxide. Now I'm in moles of carbon dioxide. How much carbon dioxide could be produced? This is a mass in grams. So now I'm going to convert moles of carbon dioxide to grams of carbon dioxide. So I know I want moles of carbon dioxide on the bottom and I want grams on the top. So I'm going to want the molar mass of carbon dioxide. So let's calculate that real quick. Molar mass of carbon dioxide. Carbon, we just said, has a molar mass of about 12.01 grams per mole. Oxygen has a molar mass of about 16 when you look it up on the periodic table. 16 grams per mole, and I have 2 of them. So 16 times 2 is 32 grams per mole. Plus 12.01, I'm going to say the molar mass of carbon dioxide is about 44.01 grams per mole. So 44.01 grams in 1 mole of carbon dioxide. So now when I do this calculation, I'm going to get rid of grams of carbon, moles of carbon dioxide. What I'm going to be left with is grams of carbon dioxide. And that's what I want. So you multiply across the top and divide by what's on the bottom. So I'm going to say 10 times 1 times 1 times 44.01 divided by 12 times 1 times 1, 12.01. And I get 36.64. Remember, the number of significant figures in your answer comes from the number of significant figures in the problem, which is 3. So I'm going to say 36.6 grams of carbon dioxide. That's how much carbon dioxide I can make from 10 grams of carbon. So I'm going to write up here what I did. I'll write below. I went from grams of carbon to moles of carbon. I went to moles of carbon to moles of carbon dioxide. I went from moles of carbon dioxide to grams of carbon dioxide. This is sometimes called a mole road. This just shows you the path that you take to go from grams of one substance to grams of another substance. You can't convert from grams of carbon to grams of carbon dioxide directly because they have different molar masses. You have to convert grams of carbon to moles of carbon to moles of carbon dioxide, and then moles of carbon dioxide to grams of carbon dioxide. So this is the mass of carbon dioxide we can make with 10 grams of carbon. Now we need to do the same thing with 10 grams of oxygen. Remember, oxygen is O2. So I want grams of O2 on the bottom, and I want moles of O2 on the top. 1 mole of O2, so if the molar mass of oxygen is about 16, the molar mass would be about 32 grams per mole. So now grams of oxygen will cancel. So now I want to go moles of oxygen to moles of carbon dioxide. So it's a 1-to-1 ratio. Remember, it's really important that your chemical reaction is balanced, because if it's not balanced and this stoichiometry step is incorrect, the whole problem will be incorrect. So now I'm in moles of carbon dioxide, and we just calculated that 1 mole of carbon dioxide is about 44.01 grams. So now let's see how much carbon dioxide we can make from 10 grams of oxygen. So I'm going to say 10.0 times 1 times 1 times 44.01 divided by 32 times 1 times 1. It's about 13.75. With 3 significant figures, it's going to be 13.8 grams of carbon dioxide. So we do all this to determine what is the limiting reactant. So remember, the definition of the limiting reactant is the one that runs out first. The limiting reactant is the reactant that limits how much product you can make. This is less carbon dioxide than this, which means oxygen is the limiting reactant. The next part of the question, well, the question that was really asked is, what is the mass of carbon dioxide that can be produced? That's called the theoretical yield. The theoretical yield is the amount of product that you make with the limiting reactant. 13.8 grams of carbon dioxide is the theoretical yield. That is the amount that can be produced. The next part of the question said, what is the mass of leftover reactant? So I have this much I have more carbon dioxide. You can't just subtract these two from each other. You need to know if I am producing, I'm only going to be able to make 13.8 grams of carbon dioxide. How many grams of carbon is it going to take me to make 13.8 grams of carbon dioxide? Then you would subtract that amount from the amount that you start with. So let's do that right down here at the bottom. So we're going to say, what is the mass of leftover excess reactant? So I'm going to write out what I just said. I already said that we can only produce 13.8 grams of carbon dioxide. So how much carbon will be left over after producing 13.8 grams of carbon dioxide? That's essentially the question that you're answering when you're answering what's the mass of leftover excess reactant. So I'm going to start with this theoretical yield. I'm going to say, how much carbon does it take to make 13.8 grams of carbon dioxide? So 13.8 grams of carbon dioxide, kind of going backwards here. 13.8 grams of carbon dioxide. I want to go from grams of carbon dioxide to moles of carbon dioxide. So I'm going to say 44.01 grams of carbon dioxide in 1 mole of carbon dioxide. It's a 1-to-1 ratio, 1 mole of carbon dioxide for 1 mole of carbon. So now I've gone from grams of carbon dioxide to moles of carbon dioxide to moles of carbon. 1 mole of carbon is about 12.01 grams per mole. So let's see how many grams that is. So I'm going to say 13.8 times 1 times 1 times 12.01 divided by 44.01, it is 3.77 with the correct number of significant figures. 3.77 grams of carbon gets used to make this much carbon dioxide. Well, I'm starting with 10 grams of carbon, and the question says, what is the mass of excess carbon dioxide left over? So I'm going to say 10.0 grams of carbon dioxide minus 3.77 grams of carbon dioxide, and it's going to be about 6.23 grams left over of carbon. 6.23 grams of carbon dioxide is left over. So this is kind of like the sandwich and the cheese example, where if you have 14 pieces of cheese and 20 pieces of bread, you could make 14 sandwiches with the cheese, but you can only make 10 sandwiches with the bread. So the amount of cheese that's left over, the amount of excess reactant, is the amount you start with minus the amount that you use. I'm going to use 10 cheese to make 10 sandwiches. So 4 cheese would be the excess reactant. That's exactly the same thing we're doing here. We're just using mass and moles and different elements. So this is definitely something that you should be prepared to do on an exam. It will include writing the chemical formula from the sentence. which will include writing and naming compounds and molecules correctly. It will include balancing the chemical equation. It will involve determining the limiting reactant, and then the theoretical yield, and it may ask what would be the mass of excess unreacted reactant. That's another thing you might hear the excess reactant called. You might hear it called the unreacted reactant, because only 3.77 grams of carbon reacts to form this carbon dioxide. So that means 6.23 grams of carbon is left unreacted or excess. So make sure that you feel comfortable with this. This is definitely something that you are going to see again.